Hi everyone, my name is Darrell Rittenberg. Thanks for listening to a quick tutorial on using TechPlot 360 to look at pressure and density gradients. I've had several people ask me questions recently about Schlieren diagrams or Schlieren images using TechPlot 360. Now, Schlieren is an optical technique looking for inhomogeneous density fields or density gradients in typically in translucent media like air. This works really well when you're looking in supersonic flow because there's large changes in the density and as it passes through the shock waves. And these density changes you can actually see in an image. Now, in computational methods, one can actually use a technique of the Shadowgraph to look at these same pressure gradients. In TechPlot, I've actually brought up something. This is very simple. It's a supersonic airfoil. We're just looking at one slice of that airfoil. The first thing we're going to do is we're going to calculate a variable. The variable we're going to calculate is Shadowgraph. So you can hit S until you get down to it. It's a relatively small data set, so you really don't need to use Calculate on Demand, and we'll go ahead and hit Calculator. Now, if you're using a code like in this case where you haven't specified field variables, you'll have to go into Analyze and say, well, let's specify those. So for pressure, we'll use pressure, and for density, we'll use density. Okay. We'll select the variables of U and V. Okay. And we'll say OK. Now we'll do the calculate. Okay, looks like it's done. Alright, now if we go into the contour variable, we'll go to number 8 and we'll select Shadowgraph. You can see that there's a large variation in the Shadowgraph function. So if we turn on contour for Shadowgraph, you may not see what you're looking for. So first thing we're going to do coloring wise, we'll look at grayscale. And now you can see the Shadowgraph in more detail. Another way to do this is using a continuous spectrum. Oftentimes the small variations get washed out if you move to continuous coloring. So I'll move this over. If we move to continuous, you'll see it goes away, and it's basically because the banded's an easier way to try to find those things, or to see that gradients. You can also use the add and subtract contours to try to put a little more detail in the fine structure. But there you have it, a simple way to calculate Shadowgraph function and to create the equivalent of a Schlieren diagram. Thanks for watching, and if you have any other suggestions, feel free to email me at d.rittenberg, RITTENBERG, @techplot.com, and I'll do my best to post appropriate tutorials. Thanks very much.